I want to take a look at a special property of exponents of powers called power of powers. Right now, there's a couple things that we know about powers. First of all, we know how powers work. So that if I have 7 to the third power, that's just repeated multiplication. And I'm going to take 7 times 7 times 7, and we should get 343. And we also took a look at the product of powers, and we saw that if we were multiplying two powers together, we took those exponents 5 and 2 and added them. So we would have x to the 7th power. If we had a product like this, remember that we're multiplying through, everything's getting multiplied. So we could rearrange this as 3 times negative 9 times n to the third times n squared. Then 3 times negative 9 is negative 27. And n to the third times n to the second, we would add those powers together and get n to the fifth. Well, what about this power of a power thing? What do I mean by it? What does it look like? And what's the result? And how can we use it? Well, when I'm talking about power of a power, it means I'm taking a power, like 2 to the fourth, and raising it to another power, where we're going to square that. Now remember, when it comes to powers, how they work is we take the base, in this case it's 2 to the fourth, and we multiply it by itself 2 times. So 2 to the fourth times 2 to the fourth. Then, when we see multiplication, what we do with those powers is add them together. So 4 plus 4 is 8. Let's take a look at another example. What if I had t to the fifth? That's a power that we're going to raise to another power, to the third. How exponents work is we would take the base, 2 to the t to the fifth, and multiply it by itself 3 times. Then, when we're multiplying products together, if we see multiplication, what we do with those powers is add them. 5 plus 5 plus 5 is going to be 15. But I'd like to shorten this process up a little bit. And if we take a closer look from the beginning to the end, when we started with 2 to the fourth squared, so right here, the fourth to the second, we ended up with 8. So how do you get from a 4 and a 2 and turn that into an 8? That's through multiplying. And so one other way that we could look at this is 2 to the fourth squared is the same as 2 to the 4 times 2, which was at 2 to the 8th. Does that property still work in our second example? Well, when we had 2 to the 5th to the 3rd, we ended up with 15. And taking a closer look at that, t to the 5th to the 3rd is the same as 5 times 3. That's how we could get that 15. So we can start to see that we have this idea of a power property. That when we see a power, x to the m, taken to another power, the nth power. So we have this power to another power. What we do with them is multiply them together. One thing that helps me keep this straight in my head is remembering the order of operations. And one thing that I've noticed, if you remember, when we were multiplying powers together, so when we had x to the fifth times x to the seventh, how do we simplify that? Was by adding their powers. 5 plus 7 is 12. So when we saw multiplication, we did addition. And now we have the power of a power property, so that when we have something like x to the fifth to the seventh power, so we have a power to a power, we multiply those two together and get 35th power. So, in relating this to our order of operations, when we see powers taken to other powers, what we do is multiply them together. So let's try a few examples. If we want to simplify 8 to the second to the third, we don't need to write this out as multiplication. What we can do is recognize that we have a power taken to another power. And so we should multiply those two powers together and get 8 to the 6th. Now that's a fairly large number. You would probably have to type it in your calculator. And what you would get is 262,144. So 262,144. With such large numbers, oftentimes we would just leave it as 8 to the 6th power to keep things nice and concise. X to the 6th squared. Again, we have a power to a power. So we're going to multiply those two powers together, 6 times 2, and we get 12. So x to the 12th. And we can just leave it like that. Something a little bit more complicated, w to the 5th to the 4th times negative 6w squared. Going through your order of operations and thinking about grouping symbols first, well, inside each of these grouping symbols, it's already simplified. Then the next thing we take care of is powers, and that's where I have a power to a power. Right, so we should simplify w to the 5th to the 4th is 5 times 4, w to the 20th times negative 6w squared. The next thing to recognize is what's going on in between the w to the 20th power and the parentheses is multiplication. And what's going on in between the negative 6 and the w squared is multiplication. So really, we're just multiplying a bunch of things together. So we can rearrange multiplication in any way that we want because order doesn't matter. So I'm going to keep the coefficient out in front and then have w squared and then multiply that by w to the 20th power. We can simplify this part, w squared times w to the 20th. Since we see multiplication, we need to add those powers together, and we get negative 6 w to the 22nd power.